Hi guys, today we're going to look at how to create a third-person camera. We'll look at how to have the camera orbit around the character, how to zoom in and out, and how we can make the character move in the direction the camera's facing. Okay, we've got a scene with a character that can run around based on player input. The character has a character controller component attached that's used to move the character around and handle collisions with the obstacles. We also have a virtual cinemachine camera set up to follow our character around. We created this scene in the earlier videos of our 3D platformer series, so take a look if you want to know how it was done. For the third-person camera, we're going to use a cinemachine free look camera. Cinemachine is an optional package that can be installed from the package manager. It provides a suite of tools that allows us to easily create different camera behaviours without writing any code. Let's delete the existing virtual camera. Then we'll create a new free look camera from the cinemachine menu. We'll drag our character into the follow field. We'll also drag it into the look at field. The cinemachine camera will now update the position and rotation of the main camera so that it follows the character and always faces towards it. In the scene view, you'll notice these 3 red circles around the character. These show the 3 different orbit radiuses of the camera. We can change the height and radius of the top, middle and bottom rigs to change how close the camera is to the character as the height of the camera changes. We'll have a larger radius when the camera is high and then zoom in as the camera gets lower. We'll set the top rig to have a height of 3 and a radius of 9. We'll set the middle rig to have a height of 2 and a radius of 7. And we'll set the lower rig to have a height of 1 and a radius of 3. Let's press play to try this out. Now we can move the mouse left and right to orbit around the character. If we move the mouse forwards, it will raise the camera and zoom out. If we move the mouse backwards, it will lower the camera and zoom in. At the moment, you'll notice that the camera is focusing on the character's feet. Let's stop the game to change this. We'll add a child object to the character for the camera to focus on. We'll set the position to 0.8 on the y-axis. Then we'll assign this as the object for the camera to follow and look at. Let's press play to see how this is looking now. Now the focus of the camera is much higher on the character. Currently, when we move the character, it doesn't take the rotation of the camera into account. We need to change the movement script so that the character moves in the direction the camera is facing. Let's recap the relevant parts of this script quickly. We're getting the horizontal and vertical axis input. We're then using these values to determine the direction of movement along the X and Z axis. We get the input magnitude, and we multiply this by the maximum speed to get the speed. We then have some code to make the character jump, which isn't really relevant to this video. We use the direction and speed to calculate the velocity, which we then use to move the character. If any of this seems unfamiliar, have a look at the earlier videos in the series where this is covered in more detail. Also, you can find a link to the full script in the description. Okay, to make the character move in the direction the camera is facing, we need to rotate the movement direction by the camera rotation. To do this, we first need a new field for the transform of the camera. We'll mark this field as serializable so that we can set it from the inspector. Then, in the update method, we'll modify the movement direction. We only want to change it based on the rotation of the camera around the y-axis. To do this, we'll create a new rotation with just the y rotation of the camera, using the quaternion angle axis method. For the angle, we'll pass in the y angle of the camera rotation, which we can get via the Euler angles property of the camera rotation. We'll set the axis of rotation to the y-axis using the vector 3 up shorthand. We'll then multiply this with our movement direction. This will apply the Y rotation of the camera to the movement direction. While we're in the script, we'll also hide the mouse cursor so we don't see it move around as we rotate the camera. As the cursor state can be changed by the operating system or Unity, we'll hide the cursor when the application gets focus. We can do this by implementing the onApplication focus method. We'll check whether the focus parameter is set to true. If it is, it means our application has focus and we can set the cursor lock state to locked. This will hide and lock the cursor to the center of the view. We'll add an else statement and set the lock state to none if the application doesn't have focus. Let's save this script and switch back to Unity. We need to drag the main camera to the camera transform field. We drag the main camera rather than the free look camera as it's the main camera that actually moves and rotates. The Cinemachine free look camera just controls the main camera. Let's press play to try this out. Now if we move the character forwards, it moves in the direction the camera is facing. Another feature we can enable is to have the camera automatically realign to face the same direction as the character. We'll stop the game and select the free look camera in the hierarchy. We'll change the orbit binding mode to lock to target on assign. This will give us the additional option to recenter to target heading, which we'll enable. Let's press play again. Now when we move to the left, the camera will try to realign, causing the character to run in a circle. And when we stop, the camera will rotate to face the same direction as the character. If we move the camera so that there's an obstacle in the way, we can no longer see the character. We're going to use another component of Cinemachine to stop this from happening. We'll click on the Extensions drop-down and select Cinemachine Collider. This will check if the view to our target is blocked and will try to automatically resolve this. We can select from various strategies. Preserve camera height will attempt to change the view while staying at the original height. Pull camera forward moves the camera along the Z-axis. Preserve camera distance changes the view while trying to maintain the original distance from the target. We'll select pull camera forward. Let's press play to try this out. Now, when an obstacle gets in the way, the camera moves forward to keep the character in view. And when the view is no longer blocked, the camera returns to its original position. At the moment, the camera moves instantly between the different views. We can improve this by adding some damping to the movement. Let's stop the game and set the damping value to 2. This determines how quickly the camera will return to its normal position. We'll also set the damping when occluded value to 2. This determines how quickly the camera will move when trying to resolve an occlusion. Let's press play to try this out. Now, when the view is blocked, the camera moves smoothly to keep the character in view. And when the view is no longer blocked, the camera returns smoothly to the original position. The final change we're going to make is to allow the camera to be controlled by a gamepad. We'll go to Edit, Project Settings. We'll select Input Manager. What we want to do is configure the right thumbstick of a gamepad to act like the mouse. To do this, we'll right-click on the mouse X setting and duplicate it. We'll change the dead value to 0.1 and the sensitivity value to 0.5. This will make the camera respond properly to the thumbstick without being too sensitive. We'll set the type to joystick axis and choose the 4th axis. This is telling Unity to treat the right thumbstick moving left and right the same as the mouse moving left and right. We'll then do the same with the mouse Y setting. This time we'll choose the 5th axis. Let's press play to try this out. Now we can control the character and the camera with a gamepad. You may find that the camera turns the opposite way to what you'd expect. If it does, you can invert the direction by deselecting the invert checkbox on the axis. Now the camera will orbit in the opposite direction. Okay, that covers everything for this video. Hope you found it useful. Please leave any questions or feedback in the comments and subscribe and click the bell icon so you don't miss the next one. If you find our channel useful and would like to help support our work, you can find us on Patreon and Ko-fi.com. Thanks guys!